Unit 3, Section 3.4. This is going to be Part 1, where we're going to cover molarity calculations and dilution calculations. So let's start with, if 6.73 grams of sodium carbonate is dissolved in enough water to make 250 milliliters of solution, what is the molarity of the sodium carbonate, and what are the molar concentrations of the ions sodium and carbonate? So first I want to write a dissociation equation for sodium carbonate, where you write sodium carbonate yields. Realize this is a dissociation equation, which is only to represent what you get in aqueous solution when a soluble compound is dissolved. So when we dissolve sodium carbonate, we're actually going to separate the cations from the anions, and we're going to get 2 sodium ions and 1 carbonate ion. And this is known as a dissociation equation. Do not confuse this with a decomposition. It is not a decomposition. This is simply a physical change where this compound was dissolved in water, and we are showing the separation of the ions when it has been dissolved in water. Now we want to determine the molarity of each of these. Notice that when I determine the molarity of my sodium carbonate, there are 2 sodium ions, which means we have a 1:2 ratio. This means that whatever molarity I find for sodium carbonate, it's going to be double that amount for sodium. But since there's a 1:1 ratio of sodium carbonate to carbonate ions, then it'll be the same amount. So let's determine our sodium carbonate's molar concentration. Remember that molarity is equal to moles over liter. We are given grams and milliliters, so I'm going to place my 6.73 grams of sodium carbonate all over the milliliters, 250. Notice I'm putting my amount of a substance over the volume. Now we're going to do a double conversion to change this from grams per milliliter to moles over liter. We'll start by bringing down our grams, and when we go to the periodic table, that's 105.99 is equal to 1 mole. And now I'm going to convert my milliliters by bringing them up. Milliliters to liter, 1 liter is equal to 1,000 milliliters. So when I do this calculation, I end up with 0.254 molar sodium carbonate. So my concentration of sodium carbonate is 0.254 molar. Remember that sodium is going to be 2 times this amount. So 2 times 0.254 is going to give me 0.508 molar for sodium. And then it's a 1:1 ratio for carbonate and sodium carbonate, so this amount will be the same, 0.254 molar for carbonate ions. Here's another example where we are only calculating from a volume and molarity the mass in grams of potassium permanganate. Remember once again that the equation for molarity is molarity equals moles over liter. And I want you to notice that 0.125 molars is the exact same as writing 0.0125 moles per 1 liter. And we're going to treat this as if it were a conversion factor. That means that it's not going to be what we start our problem out with. And so we will start with 250 milliliters of our solution. So 250 milliliters over 1 times draw line. We need to get to the point where we can insert this conversion factor into our problem. So right now we're trying to get to liters. So I'll bring down milliliter, go to liter. 1 liter equals 1,000 milliliters times draw line. Now that I've brought down liter, I can actually use this in my problem as a conversion factor right here, where I go from liters to moles by using 1 liter equals 0.0125 moles. I'm going to continue because they asked me to find my mass in grams. So though I have gotten to moles, I'm going to take it one more step and go from moles to grams. And the grams of potassium permanganate are 158.04. So my milliliters cancel, my liters cancel, my moles cancel, and I'm left with grams. The final answer to this is 0.494 grams of potassium permanganate. What mass in grams of solute in 125 milliliters of a 1.023 times 10 to the negative 3 molar solution of sodium phosphate? And what are the molar concentrations of my sodium ions and phosphate ions? So the first thing I want to do is write a dissociation equation of sodium phosphate. So I will write sodium phosphate yields. We have 3 sodium ions plus 1 phosphate ion. Now, we're trying to determine the molar concentrations of sodium ions and phosphate ions, and we are also trying to determine the mass in grams of sodium phosphate. So we have 3 different things that we're trying to determine. We'll start with the molar concentrations of sodium and phosphate. Because we are given the molar concentration of sodium phosphate to begin with, we know that because my sodium ions are a 3-to-1 ratio, that means it's going to be 3 times 1.023 times 10 to the negative 3 molar, which is going to give me 3.069 times 10 to the negative 3 molar. And then it's a 1-to-1 ratio for phosphate, so this amount will just be the same. Alright, so now that I have my answers for the molar concentration of sodium and phosphate, we can concentrate now on finding the grams of sodium phosphate with my givens. So I will take my molarity, and remember that this could be rewritten as 1.023 times 10 to the negative 3 moles all over 1 liter. And we'll use it as a conversion factor. So that means we're going to start with our 125 milliliters. So 125 milliliters over 1. We want to get from milliliters to liters because we're trying to get to where we can use this in the equation. So we're going to liters. Times, draw a line, bring down liters. Now I can actually insert this into my problem right here, go from liters to moles, and it's 1 liter and 1.023 times 10 to the negative 3 moles. We want to know our answer in grams, so we're going to go one more step, bring down moles, and go to grams of sodium phosphate. The molar mass of sodium phosphate is 163.94. And when we do this calculation, we get 0.0210 grams of sodium phosphate. And that is my final answer. This is known as a dilution equation. And I know this whenever I see the term dilute in the problem. The equation for a dilution is M1V1 equals M2V2. So notice that we are given a first volume and a first molarity, so this would be V1 and M1, 25.0 milliliters of 1.50 molar hydrochloric acid. I want to dilute that to 500 milliliters, so a new volume, and what would be the molar concentration of that new solution. So I'll plug in what I have. My M1 is 1.50 molar times my V1, which is 25.0 milliliters, is equal to, I don't know my new molar concentration, should be a 2. But my new volume is supposed to be 500 milliliters. Please keep in mind that as long as both your volumes are in the same unit, then it's going to cancel out, and so you can keep them in milliliters or you can have them both in liters. So when I multiply 1.50 molar times 25.0 divided by the 500 in order to solve for M2, I'm going to get 0.075 molar HCl. Now we're being asked to determine what is this concentration expressed in parts per million. Parts per million, 1 part per million is equal to 1 milligram per liter. So essentially we need to change this from moles per liter to milligrams per liter. So I will take 0.075 moles per liter. We don't have to change liter because that's what we want it to stay in the denominator. So I'm going to bring down 1 mole, and we're going to go to grams of HCl, which is 36.46. And then when we bring down grams, we can go to milligrams because 1 gram is equal to 1,000 milligrams. And we'll get a final answer of 2730 parts per million. And so these are the 2 answers that they've asked me to find. If you need 1 liter of a 0.125 molar sulfuric acid solution, which of the following methods would prepare that solution? So we need to determine if we perform dilution A and dilution B, which one will actually bring us to have 0.125 molar sulfuric acid. So we'll start with letter A, where we use our M1V1 equals M2V2. So M1 is 6.00 molar sulfuric acid, and V1 is the 20.8 milliliters. We want to dilute it to a new volume of 1.00 liter, so what is going to be our new molarity? So we'll plug in 6.00 molar times 20.8 equals, I don't know the new molarity, times 1 liter, which is the same thing as 1,000 milliliters. Remember that we need our units for both volumes to be the same. So when I do 6 times 20.8 divided by 1,000, we get a new molarity of 0.125 molar, which would actually make this process the correct one. But we should check process number 2 just in case it also would give us the correct answer. So we'll do letter B, where I'm going to add, this one's very tricky the way it's been worded too. We're going to add 950 milliliters of water to an initial volume of 50.0 milliliters with an initial molarity of 3.00 molar. But keep in mind that if you add 950 milliliters to 50, then your new volume is going to be 1,000 milliliters. And so we want to know what's going to be the new molarity after that. So when I plug in, I'm going to get 3.00 molar times 50.0 milliliters is equal to, I don't know the new molarity, times 1,000 milliliters. And so 3 times 50 divided by 1,000 is going to give me a new molarity of 0.15 molar. Clearly, this is not equal to the amount that we need it to be, therefore the second process would not give us the dilution that we require. Also note that each of these have a final volume of 1,000 milliliters, which is equal to 1 liter for both of them, which is what we have been asked to find if we need 1 liter of this molarity.